Can you guys hear me? Okay. So the way I structured this presentation essentially, in like first 5 to 10 minutes, we're going to take a look at the overall implementation of Solaris within the RodeoFX. And then the last 15 to 20 minutes, it's going to be real scenes from the House of the Dragon from different departments. All right, let's start with the show reel.
Try to look at this screen versus that screen.
Oh, okay. Alrighty, so when and why? Actually, shout out to everybody who worked on these movies. When and why? So when did we actually move to the Solaris and USD? So Rodeo was looking into USD itself since its beginnings in 2016. But there's always this challenge that we face. We've got hundreds of artists within the company. We've got thousands of shots in the production. So the question is, how do you safely transition, right? The way we approach this is first by focusing on our own internal animated short film. There was 128 full CG shots. And the main focus of this internal short was actually developing the Solaris and USD pipeline. After completion of this project, we took on our first client with project 1923. There was safe space of around 38 shots. And after 1923, we started to roll different other shows into this new pipeline with 480 shots for Red One, and then House of the Dragon Season 2 with 260 shots. So why did we switch in the first place? So in our previous pipeline, what we are focusing on is having like a specialized artist within specialized softwares. So you could have an environment artist within the Clarice, and then it had to be shipped to Katana and then rendered within Arnold. What this actually causes within the production is these sort of gaps, right? You've got an environment artist who does the scattering, but then you have to book another artist within Katana and Arnold so that you can get all the shading working. So in reality, how does it look like in the productions? You've got separation and gap, you've got these double bookings, and delays in the production, and of course, the worst one being the underutilized skills of the artist, because it's not that they can't do the job, it's just because everything is spread out within the pipeline, within separate softwares. Sometimes it is very hard to get one artist to work in another software as well. So with our transition to USD and Solaris, the main focus is to consolidate everything to a single software with Houdini and Solaris acting as this center point of the pipeline. And this way we can improve collaboration between different artists, we can share the setups, we can align the departments together, reduce the double bookings, and increase the speed of iterations on the shots. So how did we implement it? Within this new pipeline, we've got 3 areas of focus. First one being the USD, then we've got Solaris itself, and then we've got a automation within the shotgun and even the triggers so that we can tie everything all together. So let's take a look at the USD first. How do we compose our layer stack within the company? Starting with the payloads being different types of geometries, VDB, or let's say instancer from Houdini. Imagine you work on a dragon. Dragon has different parts, for example, the body part, the saddle part, or any technical geometry that needs to be shipped to CFX. First step in the process that we do is pack everything to what we call USD payload package. USD payload package is not something you'll find in the USD, it's something we introduced within our own pipeline, just to package everything nicely together within a single entity in the pipeline. The way we do it is as soon files are published from the publishers, we go to Solaris and we reference in every single part of the asset and different LODs. So in this case, we're looking at the creature Silverwing, which was the dragon on this show. And we're loading the body parts with different LODs. We're loading the lidar that was used for BMM. And then we're loading the saddles with different LODs as well. Once we generate these payload packages, we generate the layer stack within the shots. The way this works is, imagine you run a layer stack command. It goes through every single layer, and it grabs these payloads that were published previously. And this is how the entire graph looks like. With the payloads and the layer stacks ready, we can start our work within Houdini, starting with the USD loader. The way we structured our USD loader, it's built mostly with Houdini native nodes and some Python scripts to organize things together. Here we've got just a sublayer node loading the entire layer stack. And then we've got different modes within this USD loader that allows you to load individual layers of the USD layer stack itself. And then we've got a couple extra options if you want to reference stuff within specific place in the hierarchy. Moving on, we've got our chunks and HDAs. Chunks, well, HDAs, you guys know what it is. Chunk, essentially within our pipeline, is a network box that contains all these HDAs and nodes. And this way we can publish out a collection of these nodes as an entity within the pipeline. And it can be shared across the departments. This is an example of our templates. So in this case, this is a lighting template within the Solaris, and this is FX template within Solaris as well. And if you notice, we're trying to share essentially the shot work or like shot lighting setups in these chunks right here. To improve the sharing, what we've done, we've introduced something called global step. So instead of publishing to individual departments like layout or anim CFX lighting, we have one step called global, and this one serves as a global step for publishing shared chunks and HDAs. With all the templates, we're ready to automate. We refer to this at Rodeo as updates graph, and essentially updates graph just go through individual steps within the update process. So, getting the template, updating all the chunks and HDAs, rebuilding the layer stack, and then shipping it to Tractor. We've got these two graphs for both Nuke and Houdini, and we tie them together within the ROP network with Dispatch Nuke Rodeo that ties these two automations together. Lastly, what we've introduced in the last couple of years is this automation based on shotgun triggers. So imagine you're a lighting artist and you want to automate your first, middle, last frame every single time you receive a new cache. So what you can do within the shotgun, you can set up your automation saying that each time a, let's say, QC anim, QC CFX, FX, or layout gets approved or pushed, send an update process, gather everything latest, gather all the chunks, and render first, middle, last lighting frame for this specific shot. This way we can automate quite a lot of stuff. We had a couple of examples. For example, on Red One, we were automating a client presentation out of animation. We had a creature there with quite a lot of fur. And of course, out of Maya, you can't really see the fur. So to make a decision whether a shot is good to approve or move forward, it's always better to have full, lit and rendered creature to make the decision. This way, we were able to automate it. So animation is approved, update the layer stack, go to Solaris, gather all the latest chunks from the lighting work, and render out a automated client presentation that we can show later down the line to the client. Same way, we essentially automate any crowd post-processing on the package. You can, if you do FX or CFX, let's say you build your own setup within Houdini, and now you just want to automate it through the pipeline, you can set it up as well. And then, again, with lighting, we've got these examples of first, middle, last frames, or any basic shot QCs. This way, we can iterate faster, we eliminate quite a lot of manual tasks, and we're focusing mostly on the creativity within the company and collaboration between the departments. Now onto the examples from House of the Dragon 2. So in this case, we're going to be looking at this shot right here, which is essentially dragon flying through King's Landing. If you look at individual layers of this shot, we've got dragon, we've got the rider, we've got some crowd in King's Landing, then we've got King's Landing itself, and then a bunch of instant smokes and mist within the city. So starting with environments, first step in the process is setting up all the variants for the instant source assets. Together we use totally 366 asset variants for the build of King's Landing. Asset variant is essentially a combination of model and texture variants, and together they form an asset variant. We have some tools within our manifest to automate this process, and then we essentially, within the King's Landing group, we've got something called asset library that contains all the asset required for this build. So starting in Houdini right here, this is an environment template overview. At the top, we've got anything that is dealing with instant sources, so expanding the variants, etc. Then the middle chunk right here is what we call env builder. And then at the bottom, we do the look dev and shading within this environment scene as well, and publish it as a sublayer on top of the entire assembly. So first step in the process is expanding the asset variants. So we expand them so that every single asset variant has its own location within the hierarchy. And once this is done, we are ready to move on to our env builder. The entire build of the environments inside our company is done in SOPs. So here we have example of King's Landing, where we import the geometry. Then we used a couple of height fields to adjust the geometry based on the requirements, and then a couple of curves to create like a road setup within the city. And then we continue just classic, scattering workflow where you divide, by houses, props, vegetation, etc. And this is how it will look like at the end in the SOPs. And then we bring it back to Solaris, and that is then ready to publish within our internal publisher. Look dev is done in the similar way, so we're importing a chunk that contains look dev light rigs, and then in this chunk we do shading itself. So if you look at it, it's your classic shading workflow that you would use on any other asset, starting with a global settings, then quite a lot of primvars to drive different shading variations, and then a couple of object settings, material library, material assign, and that is then good to publish. One thing we introduced to King's Landing as well is, because we had the need to create shot-specific assemblies for different sequences, we introduced assembly variants. So we built our King's Landing as one asset, and within the asset itself, we are setting up these assembly variants, and then a layout artist within the shot would switch them based on which sequence they work on. And this is how the end product would look like. So lastly, we set up a bunch of display colors. So when we ship it to layout, to Maya, at least we've got some visual cues of how everything looks like. And these are some final renders of the King's Landing from Solaris. Moving on to assets, we're going to look at the Dragon Silver Wing, again starting with the layer stacks and the USD manifest. For the hero assets, we always declare 2 manifest and 2 layer stack. This first one, manifest and layer stack, is for the Dragon and the asset itself. You can see different parts, so like the body part, different concept, lighter, saddle, and saliva of the Dragon. And then we set up second, a manifest and layer stack, which is used for reviewing itself. Here we import the Dragon, but we also create a specific camera for this asset, and we import any light rigs or any reference asset that we need to build this hero asset. Imagine you're working in modeling, texture, shading, hair, let's say. We're using these layer stack and these cameras to have exactly the same frames across all the departments within the asset pipeline, so everybody is using the same setup. So looking at the shading template, the way we work here in the middle, we essentially import this review bundle that contains the Dragon and the camera and everything else that we've added in. And look dev artists would usually do the work on the left side of the template. Again, the classic, you create your own collections, you do any material variations, print vars on the asset if you need to, and then you assign the materials, any render geometry settings if you need to. And then next step in the process is either you publish it or we essentially reference it back to the main branch, the main asset review branch. And you've got your interactive backdrop right here or any studio light rigs that you want to use right here. The Dragon scene builds exactly from this principle. It just looks a bit more robust. So let's go through it as well. On the left side, we've got the classic shading, interactive workflow. And here we have something what happened with our Dragon asset is actually shading artist, because he was working in Solaris, he created his own ground with height fields and scatters within the shading scene. So this is an example of this cross functionality of Solaris, where you don't have to necessarily import new assets, but if you want to, you can literally just build it straight in your look dev scene and continue working. Here we have the middle part is again loading not just one review bundle, but we actually had multiple of them with the different poses. This is, for example of client pose of the Dragon within the shading scene. And then we have different cycles, right? So the soaring cycle, we had some close-ups of the face, we had the close-ups for the saddle, and then we had some animation cycles on the facial expressions of the Dragon. And then lastly, again, it's the same principle, just combination of different poses and different light rigs that we then render out. And here are some of the final renders. So this is the soaring cycle. Got some close-up for the mouth, the saddle, and then to QC the eye movements right here. For the shot work, in this shot we had a crowd. The crowd is actually done with Golem in Maya, but then we do post-processing within Houdini. The crowd packager works in a way where we load the Golem USDC file, and we essentially set up a bunch of stuff for the proxy preview, and then a couple of optimization, and then reassignments of the shading from the hero assets onto these crowd agents. This is done essentially with the same, free softwares that we use. So in Shotgun, when we approve a crowd daily, there's automation trigger that gathers everything from the pipeline, does the crowd packaging, and then renders a crowd QC. For CFX and FX, we work in subs, so we use Solaris mostly for rendering, and our intention here is mostly, sharing the chunks from lighting. So let's say if you have a lighting artist working already on a shot, we always try to ask artists, hey, let's grab these chunks from lighting, add it to our own template, CFX FX template, and use that. The FX workflow and CFX workflow, essentially on the left side, we've got the main branch from the shot, and right side, we've got the backdrop where they essentially do their own work. I've got here an example of VDB instancing that we did for King's Landing, and the workflow is essentially the same as for environments. So we're loading the library of the volumes, then doing the expansion of all the asset variants, and then we're going into the SOPs, where we set up the point cloud with all the attributes needed. Then we're going back to lobs. We import everything to the instancer. And here we've got the final result of this instancing of the volumes within the Solaris. And same thing was used for the ground fog as well. One thing we used in CFX is context options. So here we declared a bunch of context options for different parts of the Dragon. So let's say you want to run the sim on the wings, but you don't want to run the sim on the saddles. You could enable and disable these checkboxes, and this reflects later inside the SOPs and also inside the ROPNet within the Solaris. And yeah, one thing we have added here is also like a checkbox just to kick off like a QC tech passes. So if this one was checked on, we are essentially rendering a bunch of technical passes for review. Lighting workflow. So within the lighting, the main challenge is always, okay, how do we work all together within the same template on multiple shots? The way we approach this is essentially the first couple of chunks are global settings that tie to the context options right here. This is all maintained either by the lighting soup or HOD. Then we move down to the project level chunks that are maintained by your lighting lead or lighting soup. We've got some collections here declared. We've got all the light rigs within the subnet and render passes. And then we move on to the shot work, where we have multiple artists working on different shots. The way we approach this is every single artist, let's say you get assigned a shot, you're responsible for a specific HDA that contains any of the lighting edits or lighting optimization that you then publish. And that essentially lives within the chunk that can be shared across the different departments. And of course, like if you need to remove something from that HDA, let's say here we've got both the lighting edits and shot optimization within one HDA. If you want to skip that in different steps, for example, FX or CFX, we just drive it with simple reference to the environment variable that calls the step that you work on. And then lastly, all the ROP networks. We've got at the very end, we have the edit context options that essentially switch different passes. And we go to the ROPNet, where we have an HDA called ROP fetcher. And this essentially fetches all the ROPs based on the expression and then send it to the farm. Here we have an example. For example, this is essentially multiple different slapcoms from Nuke. And we use this dispatch rodeo Nuke node to essentially switch between different slapcoms that you want to do. And that is the final shot right here. So what's next for us? The big part is optimization. You can imagine with all the automation that we do, you can declare a bunch of things in Shotgun and automate quite a lot of stuff. We have a big focus on optimization across the board. And then also quite a lot of onboarding and this assisting of different artists to move into Solaris. There's like big pool of artists who worked in Claris before or Katana, and now they need to transition to Solaris. So we try to assist them as much as we can. Lastly, if you guys are interested, there is a full breakdown. It's got 4 minutes. I'm not going to play it here because it's quite long, but if you're interested, you can check it out on the YouTube. Thank you so much, and yeah, if you have any questions, now is the time.
Any questions? No.
Hey there.
Hey.
Thank you for the presentation. I was going to ask, lighting artists, they've been iterating using, you've been using Tractor, so it's RenderMan, or they've been iterating using Karma inside of Houdini?
I don't think I understand the question. Can you
So the lighting artists, when they've been working on a lighting using the RenderMan inside of Houdini and Solaris, or they've been using Karma and then sending it to Tractor to render it with RenderMan.
So we render in Arno, And Tractor is essentially just a software that manages the renders on the farm. So it's like two separate things.
Okay.
You got your render engine, and then the Tractor that handles all the rendering on the farm and cloud. Yeah.
Hey, thanks for the presentation. I was wondering about the HDAs you said that each lighting artist is responsible for. Would that be on like a per scene basis? So like there's a general lighting setup for a scene and then like each shot gets its own, or like how does that HDA get like transferred to other artists? Or is it like an iterative process where like anyone can iterate on the same HDA or?
So usually you will have a artist assigned a shot, right? Like as a lighting artist, okay, I have an assigned shot, and for this specific shot, I'm creating an HDA within which I create all the lighting edits, all the optimization, etc. And then I just publish it to the pipeline so that when everything is built again, it grabs everything latest of what I've done.
Cool. Thank
Does
you.
that answer the question?
Yeah, totally.
Perfect.
I was curious if you could expand more on the chunks. They looked like, you said net boxes, but what's the advantage of not just breaking that down into an HDA? What do you get from the chunks that you wouldn't necessarily get from an HDA?
I think a good example is the actual shot work that we have, right? You've got a chunk that contains all the switches, and then we've got individual HDAs that belong to the shots. So let's say you want to share the entire sequence setup to FX or CFX. Instead of sending individual HDAs, you could do that, but instead of that, you can just import one group, one chunk that essentially wraps everything together, and then you can pass it along much more easier.
And are those version controlled or?
Yes, yeah. Everything is version controlled, and you can essentially both chunks and HDAs, you can publish them on like facility level, then project, so it cascades all the way down to the shop.
Thank you.
Anyone else? No? Okay, thank you, Peter.
Oh, thank you very much.